Okay, so we're starting into a little bit of a unit on triangles and proving triangles congruent. So over the next few couple days, couple weeks, we're going to be talking about different ways to prove triangles congruent. The first theorem we're going to learn is just a sort of a simple, straightforward theorem. It says if two angles of a triangle are congruent to two angles of another triangle, then the third angle of both triangles are also congruent. Um, and this is sort of easy to prove because we remember from the triangle angle sum theorem that the angles of a triangle add up to be 180 degrees. So if two angles of one triangle are congruent to two angles of the other, then they have to be congruent. The third angle has to be congruent because both triangles are adding up to be 180 degrees. All right. So here's a couple of examples we'll look at using this theorem. We have to use both the triangle angle sum theorem and this theorem to kind of get both of these angles. I have two triangles down here. I have triangle ABC with angles 55 and 65. And then I have triangle XYZ with angle 55 and 65. And note for this particular theorem, the lengths of the sides doesn't necessarily have to be the same. All right, so the angles can be the same without the triangles actually being exactly alike. Um, if we're looking here at these triangles, if I want to find angle C, I need to use the triangle angle sum theorem, right? So angle C, if all these angles add up to 180, then what I can do is take 180 and subtract off the sum of these two angles, and that'll give me the measure of the third angle. So if I add those two together, that'll be my answer. All right, so angle C is going to be equal to 180, and these two sum together to be 60 plus 60 would be 120. So your angle C is going to be 180 minus 120, which is 60. So that you find using the triangle angle sum. All the angles of a triangle add up to 180. And then you can use the theorem that we have today basically to get angle Z. You don't have to go through all that work again. Angle C has to be equal to angle Z because these two angles are congruent to those two angles. So we can say that angle Z is also equal to 60 degrees. And that's all there is to it. Take a second, pause the video, and see if you can figure out angle C and Y in this example. Okay, so if we want to find angle C, we're going to do exactly like we did before. Use triangle angle sum. They add up to 180. So if we subtract off the sum of these two angles, we'll know the third angle here is C. So the sum of those is 70 plus 45. So angle C is going to be equal to 180 minus, 70 plus 45 is going to be 115. So that means that angle C has got to be equal to 65 degrees. All right. And then using this theorem that we learned today, you can figure out that angle Y also has to be 65 because this angle and this angle are equal, this angle and this angle are equal. C and Y have to be equal as well. So angle Y also is 65 degrees. Okay, so there's one example of how that can be used. Here's another example where we're trying to find the parts of a triangle. A couple of things to note. First, this little symbol here, little tiny triangle, that is the symbol for a triangle. So it's one of the most straightforward symbols in geometry. This reads triangle ABC is congruent to triangle DEF. So we want to find the measure of the angles. If we want to do that, here's the thing. When we write a triangle is congruent to another, what that means is that each individual letter represents an angle of that triangle. So just as sort of an aside, triangle ABC would look sort of like this, ABC. Basically, we call this triangle ABC because it has angles A, B, and C. And we know that that's congruent to triangle DEF. All right? And basically, the rule here is the order in which you write them those angles, if these triangles are congruent, then the position of the letter represents the angles that are congruent. So here A and D are congruent to each other. B is in the middle and E is in the middle, so they are equal to each other. C is on the end and F is on the end, so they are equal to each other. So what we do is we're going to look at these two angles. It says measure of angle A is equal to x plus 15. So A is in the first position. So angle D is equal to 2x. D is also in the first position, so that we know that these two angles have to be equal to each other. So we can set that up. X plus 5 is equal to 2x. And then if we solve for x, we can get the measure of the angle. All right, notice we have x's on both sides, so we need to get them together. My suggestion here is to subtract x from both sides. And that leaves us with 5 is equal to 2x minus x is x. So there is the measure of x. If you wanted to find the measures of the angles, so angle A is just basically plug in 5 where you see x here. So that's going to be 5 plus 15. So angle A is equal to 20 degrees. All right. And for angle D, if you wanted to find angle D, you're expecting these to be congruent. You're expecting to get 20 here as well. But if you want to test it out, then you need to put in 2 times 5 is 10. So x plus, I see where I made a mistake right there. So we'll scratch all that out. This is x plus 15. So x is actually equal to 15. That's where I made a mistake. That's why you want to check your work to make sure you're right. All right, so x is actually equal to 15. I made a little copying error here. So if you want to find the angles, then angle A is equal to 15 plus 15, which is 30. And then you can expect angle D to be equal to that. But to test it, you put in 15 for x, so 2 times 15 is 30, and you know you're correct. All right? Take a second and try the second problem and see what you come up with. Pause the video, and then come back in a minute to see if you're right. All right, so in number 2, we've got C and F. We just want to double check to make sure C and F are in the same location, position written up here, and they are. They're both on the end. So C is going to be equal to F. So basically you take that formula, 4x plus 6, set it equal to 2x plus 10, and then you can solve for x. So we want to subtract 2x from both sides. So 4x minus 2x is 2x plus 6, and that's equal to 10 because those cancel. And then to get x by itself, we need to subtract 6 from both sides. So we get 2x is equal to 10 minus 6 is 4. And then we need to divide both sides by 2. So 4 divided by 2 is 2. So x is equal to 2. If we want to figure out the angles, angle C is going to be everywhere we see x here, we're going to put 2. So that's 4 times 2 plus 6. 4 times 2 is 8. 8 plus 6 is 14. Now we're going to expect angle F to be equal to 14 as well, or we made a mistake. So 2 times, we're putting in 2, plus 10. 2 times 2 is 4. 4 plus 10 is 14. So we know we're correct. If you have any questions on that, please bring them to class.